Hello champion, I'm teacher Adam. Welcome to my math class. Today we are going to learn about irrational numbers. What are irrational numbers? So there are two terms. We have rational. We say the definition you need to know about rational. Rational, we say, is any number that can be written as a fraction. So any number that can be written as a fraction in the form of a over b. So we say, in other words, we say all fractions are rational. All fractions are rational. And we say, it must be possible to write in the form of ab, where a and b are both integers. And we know that b cannot be 0, because if b becomes 0, it becomes undefined. So, and we say, for example, we say all fractions, for example, maybe example fractions, we say I have 1 over 3, 3 out of 4, 7 out of 9, etc. All fractions are rational, correct. Then we go to what is an irrational number? We say an irrational number, irrational. So we write that. Irrational numbers. What is an irrational number? We say an irrational number is any number that cannot be written as a fraction. It cannot be written as a fraction in the form of a over b. For example, we know a and b are integers and ab is not in simplest form. So we say, for example, this normally are all non-terminating, and non-recurring. All non-terminating and non-recurring. They are irrational numbers. So for example, all surds are irrational. What's a surd? What is a surd? What's a surd number? We say a surd is a square root of a number that is not square. So for example, we know e.g. example is square root of 3. 3 is not a square number, or square root of 5, or square root of 7. If you find the square root of a square number, you get a whole number. That will make it rational. But we say irrational is square root of non-square numbers. So if you have square root of non-square numbers here, you get an irrational. Or you have a recurring, digits that recur. They occur and they don't have an end, continuous. Like for example, 1 over 3, you just get 0.333333 continuous. Very good. And then now, in the case of when you're given, let's say maybe you're told to convert, for example, pi is an irrational because it continues, and then you're told to convert it into rational. So for example, we have let's say example, we have let's say 0.125, and this 5 repeats, and then they say convert the recurring decimal above to or in the form of a over b. So it means they want you to change 0.125555555. Means the 5 is the one being repeated here as a fraction. What do we need to do? Basically, this is what you're supposed to do, candidate. You take you say 1 rational is equivalent to 0.125555. You get Roman 1. And then when you multiply by 10, it means you're moving the decimal you're moving the decimal to the right. So you multiply both sides by 10. You get 10r is equal to 1.255555. Then you continue, Roman 2. And then you get, you multiply again by 10. By 10, what do you get? You get 100r is equal to 12.55555. Continuous, Roman 3. Our idea here when we're trying to learn how to convert, irrational numbers to rational, we want the decimal part to be 0. So our idea, we just want the decimal part to be 0. So if you want the decimal part to be 0, what do? In that case, we multiply again by 10. You get 1000r is equal to 125.5555555. Now, our third equation, if we take our fourth equation minus our third equation, we will get 0 on the decimal part. So if we take that one, so you say now 1000r is equal to 125.555 continuous, Roman 4, minus Roman 3, which is 100r is equal to 12.555 continuous, Roman 3. This one will give you decimal part will be 0, 0. And then 5 minus 2 is 3, 2 minus 1 is 1. And then 1 minus 0, it's 1, 113. And then this one will be 900r. And then make r the subject. It will be 900r is equal to 113. Divide by 900, divide by 900. So r is 113 over 900. This becomes your... We understood also what we need to know in these tips. For example, when we said SADs, we said all SADs, and we also have some laws that pertain SADs. We say rational numbers that you should recognize are, for example, we know pi is a rational number, square root of 2, square root of 3, square root of 5. All these ones are rational numbers. And we need to know, principles or laws of irrational numbers. Laws of irrational numbers. So we have pi, square root of 2, square root of 3, square root 5. All these non-square numbers, they are irrational numbers. So laws of irrational numbers, for example, if you have, if you're finding square root of a times the square root of a, what do? When you're multiplying numbers that have the same base under the square root form, you get the same number. For example, square root 2 times square root 2, this square root times square root, it cancels itself and you get your answer as 2. As simple as it is. If you find square root 3 times the square root of 3, so these ones cancel each other and you remain your answer as 3. This is a principle in multiplying. Another principle in division, like for example, root 4 divided by root 7 divided by root 7. The same principle. So we have root 7. We say root 7 divided by, we using calculator, divide by root 7. We have to confirm. What do we get? We get 1. Why? Because, and when you have root 2 multiply by root 2, what do we get? We get our answers 2. So root 7 divided by root 7, what we know, if you're dividing SADs, we know root, square root, square root. This one cancel each other and you remain with 7. So 7 over 7 is 1. 7 divided by 7 is 1. So with the division, its total is a bit different. Even if you say square root 2 and then divide by, let's say divide by square root 2, what do we get? We'll get 1. So we have to be careful on our choices. So laws, when it comes to multiplying and finding the numbers, we have to be careful what is examined. So let's do some questions that containing SADs. Like for example, explain why root 3 is irrational. You say root 3 is irrational because it cannot be written as a fraction. Root 3 is an irrational number because it cannot be written as a fraction. It cannot be written as in form of a over b. So if it cannot be written in form of a over b, that's why it's irrational. That's it. With these numbers, sometimes you might be given, let's say you're given, you might be given this kind of concept. Let's say we want to say maybe you are given questions in different format. They want you to convert, let's say convert 0.13, so 0.13 to fraction, or write it as irrational, or write it as a fraction. What we need to do, we just need to know one rational, which is fraction, is the same as 0.13. These dots, if they're on 2, it means 13 repeats every time. 13, 13, 13. They reoccur, they repeat in the same pattern. 13, 13, 13, 13. If they say is only 0.13 and then they say only 3, that means this one it will be 0.13333. And sometimes you might be given, examiners can put this one 0.125, and then they put dot between here and here. So what you need to understand, that this pattern will be 0.125, 125, 125 after every round. After every 3 rounds, it's shifted that way. So you'll be able to bring back into fraction. So the same here. So our idea is to get the decimal part as 0. So we understand if you find this pattern, you multiply by 10 here, you get 10r is equal to 1.3, 1.3, and then 13, 13, 13, 13 as you continue. And then you multiply by 10 again, you get 100r is equal to 13.13, 13, 13, 13. And then you end up with Roman 3. So with Roman 3, then what you need to do, you take Roman 3 minus Roman 1. 1r is equal to 0.13131313. Then you get Roman 1. So you see here, with the decimal part, you get 0, 0. And then here you get 13. 100r minus 1r is 99r. Therefore, you make r the subject. 99r is equal to 13. Divide by 99, divide by 99. So r is the same as 13 over 99. And you get your correct answer, champion. That's the most commonly asked question. It's the most commonly asked question. The rest, whereby you're supposed to apply your understanding, whereby you're supposed to apply the understanding, is as simple as it is, because some questions, they just want you to apply the law. For example, let's say maybe a question comes in this format. You have 2 into bracket, maybe root 3 times 2 root 3. When you have these kind of questions, what are you supposed to do? We understand what we understand. We know, even on the laws of one law about it, when you have a root b times c root b, what happens? What we understand, you'll keep you'll multiply the coefficients by themselves, and root b by themselves also, root b. So we understand root b, you only get b. So, and you get b multiplied by ac. This will be your answer. This is a law that all mathematicians or all mathematics students need to understand. Are we together? Champion? So normally on your IGCSE math, they normally test on this area. So majorly they will have questions on this area, and you need to understand. Like, understand on which angle are exam style questions coming, and where what is the most important thing for me to be able to understand. So all these kind of questions, and actually understanding all the laws. Maybe we can do some questions on the same concept on converting. For example, here they say circle the rational numbers. So here they say they want you to circle the rational numbers. You have been given pi, you've been given square root of 9, you've been given 0.111, and then you'll be given 4, you'll be given root 2, and then you'll be given a third. So circle the rational numbers. This one can only be written as a fraction. This one can be written as fraction. It's the same as 4 over 1. A whole number, you divide by 1. Root 2 is irrational. This one is irrational because you can see there it's continuous. Like this one is irrational, but this one is not irrational because square root of 9 is 3, and 3 can be written as a fraction as 3 over 1. So it's not. Oh, so they said circle the rational numbers. Here they say circle the rational numbers. So irrational, we have said. The rational, irrational, we have pi, we have root 2. But for rational numbers, 9, 4, 1 over 3, those ones are called rational numbers. They can be written as a fraction, and 1 over 3 itself is a rational number. Are we together? And then you say here we have, Katie says 0.66 is irrational because it is a recurring decimal. Is Kate correct? Explain your answer. Yeah, Kate is correct because 6 is recurring and there is no way there is going to be an end. Write down a rational number. Rational number is any number that can be written as a fraction. So my answer will be 1 over 4. Yeah? My answer will be 1 over 4, or you can say 2 out of 5, or you can say 3 out of 7. Yeah, write down an irrational number. An irrational number, just write any number that cannot be written as a fraction. For example, root 3. Yeah, that's it. 7 plus 10, you get 17. Divide by 2, you get maybe 8.5. So circle the rational number. So you need to understand which one can be written as a fraction and which one cannot be written as a fraction. All this concept and simplifying, you need to understand, and understanding the principle. Thank you.